morning, guys. So today we are going to discuss some problems or examples on a Jacobian matrix. Okay, so such type of problems or examples will be asked for 8 marks in your examination. So here is the example. Here in this example it is given that they have given this figure and they have mentioned the cos point, means the natural coordinates have given here is equal to 0.5773, 0.5773, means the values of zeta and eta are given. Also from this figure you will get the coordinates for coordinates means x1 y1 x2 y2, means this first point is your x1 y1, this is your x2 y2, this is your x3 y3, and this is your x4 y1. Okay, so the coordinates for this all nodes are given. x1 y1, x2 y2, x4 y4, the values of these coordinates are given. And okay, and it is asked here, it is asked to find out the or determine the Jacobian matrix. Okay, so we know that the Jacobian matrix J, it is given as J is equal to dou x by dou zeta, dou y by dou zeta, and dou x by dou eta, dou y by dou eta. This is the Jacobian matrix. Okay, so we need to find out these 4 terms: dou x by dou zeta, dou y by dou zeta, dou y by dou eta. Okay, so first we will find out first term, dou x by dou zeta. So how to find out dou x by dou zeta? Okay, so as we know that the x and y coordinates can be determined from this natural coordinates by using this formula. X is nothing but n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. Similarly, y can be determined as n1 y1 plus n2 y2 plus n3 y3 plus n4 y1. Okay, here n1, n2, n3 and n4, these are the shape functions in natural coordinate system. Okay, so first we need to find out the shape functions. First we need to know the formula for n1, n2, n3, n4. Okay, as we know that the n1, n2, n3, n4 formulas are given as. So if we write this x in terms of this zeta and eta, then we will get. Okay, so this x can be written as n1. So n1 can be written as 1 minus zeta, 1 minus eta divided by 4 into x1 plus n2 is what? 1 minus zeta. N2 is what? Actually, how to remember this system? This is your zeta, this is your eta. So this is your minus 1 comma minus 1 point, this is your plus 1 comma minus 1 point, this is your plus 1 comma plus 1 point, and this is your minus 1 comma plus 1 point. Okay, so from this point, this is related to your n1. So n1 you will get 1 minus zeta, 1 minus zeta. So 1 minus zeta, 1 minus zeta. For n2 you will get 1 plus zeta, 1 minus zeta. 1 plus zeta, 1 minus eta divided by 4 into x2. Okay, then similarly plus n3. n3 is what? 1 plus zeta, 1 plus eta. 1 plus zeta, 1 plus eta divided by 4 into x plus finally last one for n4, 1 minus zeta, 1 plus eta. 1 minus zeta, 1 plus eta divided by 4 into x. Okay, so you will get this x in terms of zeta and eta. Now the first term of this Jacobian matrix is what? Dou x by dou z. Means what? We need to take derivative of this x with respect to zeta. So here, if we take the derivative of x with respect to zeta, we will get d by dou zeta of this x is nothing but dou by dou zeta of this whole term. Okay, so first here we will take a derivative of this first term with respect to zeta. Okay, here we are going to take derivative with respect to zeta. So this remaining term, this term will be your constant. So it will become 1 minus theta into x1 divided by 4 into derivative of this with respect to zeta. Now with respect to zeta, 1 is constant. So derivative of 1 with respect to zeta is equal to 0. Derivative of zeta minus zeta with respect to zeta, it will become minus 1. So this will become minus 1. Okay, then plus. Similarly here, this term will become constant because we are taking derivative with respect to zeta only. So this will become constant. So this will become 1 minus theta times x2 divided by 4. This is constant. Now we need to take derivative with respect to this bracket only. So with respect to 1, 0, with respect to zeta, 1 into 1. Then plus for this term, again this term will become constant because we are taking with respect to zeta. Okay, so 1 plus theta into x3 divided by 4 into, now with respect, if we take with respect to zeta, this will become 0, with respect to 1 will become 0, and with respect to zeta will become 1. So into 1. Okay, and finally plus for last term, this will become again here, this term is constant. So 1 plus theta into x4 divided by 4. Now with respect to zeta, for 1, 0. For minus zeta, with respect to zeta, minus 1 into minus 1. Okay, so in this way you will get the derivative of this x with respect to zeta. Okay, so now just here we will simplify these terms. So dou x by dou zeta will become equal to, now but this term will become minus 1 minus theta times x1. If we take this 4, 1 by 4 as a constant, then finally it will become 1 by 4 in bracket this minus 1 minus theta times x1. Okay, so we can write minus x1 times 1 minus theta plus x2 times 1 minus theta plus x3 times 1 plus theta, and here it is minus 1, so it will become minus x4 times 1 plus theta, and bracket complete. Okay. So in this way you will get dou x by dou zeta. Then next thing is what? If we take derivative of this y. Okay, so here common terms are n1, n2, n3 and n4. These are common terms. Only difference is what? y1, y2, y3 and y4. It is replaced from x1, x2, x3, x4. Okay, so if we take dou y by dou zeta also, so dou y by dou zeta also, because here we are taking derivative of y with respect to zeta. So it means we are taking derivative of this term with respect to zeta, derivative of this term with respect to zeta. Similarly, this term with respect to zeta, also this term with respect to zeta. It means what? Only x1, x2, x3 and x4 will be replaced from this result. So simple step is what? Replace only x1, x2, x3 and x4. You will get dou y by dou zeta, because we are going to take dou by dou zeta of this n1, n2, n3 and 4, which actually we have determined in dou x by dou zeta. So only replace x1, x2, x3, x4. You will get dou y by dou zeta. So this will become 1 by 4 into minus y1 times 1 minus eta plus y2 times 1 minus eta plus y3 times 1 plus eta minus y4 times 1 plus eta. So in this way you will get these two terms, dou x by dou zeta as well as dou y by dou zeta. Okay, so just we need to now calculate these values. Okay, so dou x by dou zeta will become, so dou x by dou zeta. So now here 1 minus eta, 1 minus eta, 1 plus eta, 1 plus eta. So first just calculate 1 minus eta value and 1 plus eta value. So if we calculate 1 minus eta, so 1 minus eta is equal to 1 minus eta is what? Eta is given equal to 0.577. 0.577. So this will become equal to 0.4226. 4226. And if we take 1 plus eta, then it will become 1 plus 0.577. For simplicity we are doing this. So it will become 1.577. Okay. So finally what will become? So if we put 1 minus eta and 1 plus eta value into this equation, also if we put x1, x2, x3 and x4 values, then we will get 1 by 4 into minus x1. x1 is what? x1 is 0. 0 into 1 minus eta is what? 0.4226. This is your first one. Then second, plus x2. x2 is what? x2 is equal to 60. 60 into 1 minus eta. 1 minus eta is what? 0.4226. 0.4226. Okay. Then plus third, x3 is what? x3 is equal to your 60. So 60 into 1 plus eta is what? 1 plus eta is equal to 1.57. 7 plus, okay, here minus. So minus x4 is what? x4 is equal to 0. 0 into 1 plus eta. 0 into 1 plus eta, 1.577. 1.577. So in this way you can calculate this dou x by dou z. Okay, so if you calculate this value, you will get dou x by dou zeta equal to, if you calculate this dou x by dou zeta, you will get dou x by dou zeta is equal to 30. Okay, so similarly here, this is first we need to simplify this, or you can directly put the values here. So dou y by dou zeta what will become? Dou y by dou zeta is equal to 1 by 4 in brackets minus y1. So from this figure y1 is equal to 0. So this term will become 0. 0 into this 1 minus eta, actually it is what? 0.4226 plus y2 is what? y2 is equal to, y2 is also 0. So 0 into this 1 minus eta means it will become 0. 4226 plus y3 is what? y3 is equal to 10. 10 into 1 plus eta. 1 plus eta is equal to 1.57. And finally minus y4 is what? y4 is equal to 10. 10 into this 1 plus eta. 1 plus eta is equal to 1.577. Okay, so if you put, or if you calculate this equation, you will get dou y by dou zeta as if you calculate this equation. Okay, so this will become 0, this will become 1, so 0. So 10 into 1.57 minus 10 into 1.57. So this subtraction will become also equal to 0. This term will become equal to 0. Okay, so in this way you will get dou y by dou zeta. So dou x by dou zeta is equal to 30 and dou y by dou zeta is equal to 20. So from this first derivative, or if you take the derivative with respect to zeta for x and y, you will get this 30 and 0. Now next is what? Second remaining two terms are what? Remaining two terms are dou x by dou eta and dou y by dou eta. So So we need to find out now these two terms. So let us find out these two terms. So as we know that the same procedure will be applied here. So for example, x is equal to 1 minus zeta 1 minus theta divided by 4 into x1 plus 1 plus zeta 1 minus theta divided by 4 plus 1 plus zeta 1 plus theta divided by 4 plus 1 minus zeta 1 plus theta divided by is your x. Okay, so first, so here we need to find out dou x by dou eta. So dou by dou eta of this x. So just in previously we have calculated. So similarly we will apply the same procedure. Means we need to take now derivative with respect to eta. Okay, so take derivative with respect to eta. It means this term will become constant. Means x1 times 1 minus zeta divided by 4 into with respect to eta, with respect to 1 0, with respect to minus zeta minus 1 plus here this term x2 x3 x. So this term will become constant 1 plus zeta, sorry, x2 into 1 plus zeta divided by 4 into with respect to eta, with respect to 1 0, with respect to minus zeta minus 1 plus for this term again this term will become constant 1 plus zeta x3 times 1 plus zeta divided by 4 into with respect to eta, with respect to 1 0, derivative of eta with respect to eta will become 1 and plus, but I will write this term here only. Okay, right. Plus again this term will become constant x4 times 1 minus zeta divided by 4 into derivative of eta with respect to this term, with respect to 1 0, with respect to eta it will become. So in this way you will get this derivative. So we need to just simplify. So dou by dou x by dou eta will become equal to. So we just need to simplify this equation. So what will become? This is minus 1. So minus x1 times 1 minus zeta divided by 4. Or if we take 4 as common, 1 by 4 as common, so 1 by 4 into minus x1 times 1 minus zeta. For this term, it will be minus x2 times 1 plus zeta minus x2 times 1 plus zeta. For this third term, x3 times 1 plus zeta, because this is plus 1. So x3 times 1 plus zeta, and for this last term this is also plus 1. So plus x4 times 1 minus zeta plus x4 times 1 minus. In this way you will get this equation. Okay, so now we need to just put the values of 1 minus zeta and x1 to x4. So, but from this equation we can write dou y by dou zeta also. So dou y by dou zeta will become dou y by dou eta will become, because here also we are taking derivative with respect to eta. Actually we have taken this derivative in this equation, so we need to just put down, or we need to just replace the x1, x2, x3, x4 values, and you will get the dou y by dou eta. So it will become 1 by 4 into minus y1 times 1 minus zeta minus y2 times 1 plus zeta plus y3 times 1 plus zeta plus y4 times 1 minus. So this is, it is so simple. Okay, just we are eliminating just few steps. Okay, so for time consuming purpose. Okay, actually you can use this procedure or this simple steps in your exam also. Okay, so now we need to just put the values in. So first we need to calculate what is the value of 1 minus zeta and what is the value of 1 plus zeta. So 1 plus zeta and 1 minus zeta. So as we know that, so 1 plus zeta value will become 1 plus zeta. 1 plus zeta will become 1.5773 and 1 minus zeta will become 0.4226. Okay, so just put these values in this equation. You will get dou x by dou eta. Okay, dou x by dou eta is equal to 1 by 4 in bracket minus x1 is what? Your 0. 0 into this value will become 0. 0 into this 1 minus zeta, it will become 0. Minus x2. x2 is what? x2 is equal to 60. 60 into 1 plus zeta. 1 plus zeta is what? 1.57. Then plus x3. x3 is what your? x3 is also 60. 60 into 1 plus zeta. 60 into 1 plus zeta is what? 1.577. Plus x4 is what? x4 is also equal to 0. So this value will become 0. And finally, you will get dou x by dou eta equal to, actually this is 0, this is 0. And if you see, this is minus 60 times this value plus 60 times this value. So this will become 0. So dou x by dou eta value will become 0. Okay. Now next is what? Dou y by dou eta. Okay. So if we dou x by dou eta is equal to 0. Now, if we put the values here only, you will get dou y by dou eta as 1 by 4 in bracket minus y1 is equal to 0 actually, because y1, x1, y1 values are 0. Minus y2 is also equal to 0. Plus y3 is equal to 10. 10 times 1 plus zeta, 1.5773. Plus y4 is also 10. 10 times 1 minus zeta is equal to 0.4226. So you will get 1 by 4 into 10 into this is 15.5773 plus 10 into this 4.22. And if you calculate this, you will get 5 plus 15 plus 4 20. 20 by 4 equal to 5. So dou y by dou eta value equal to. So in this way you will get these 4 values. And finally, your Jacobian matrix J will become equal to dou x by dou zeta, dou x by dou eta, sorry, dou y by dou zeta, dou x by dou eta, and dou y by dou eta. So it will become equal to 30,005. So this is final Jacobian matrix. So in this way you will get this Jacobian matrix. Okay, so this is the procedure that you can solve. By using this procedure you can solve for Jacobian matrix, and such type of examples will be asked for 6 to 8 marks in your examination. Okay, so try to solve such type of examples at home. Okay, so here I am concluding this lecture, and from next lecture we will start our 5th unit, that is finite element analysis to heat transfer problems. Okay, so in this 5th unit we will see, first we will see the derivation for conduction as well as derivation for convection problems. Then we will solve some problems related to your conduction and convection. Okay, so here I am concluding this lecture. Thank you.